Hey everyone, today I'll try to show a simple binary patch. We'll see how quickly it will go, but I'll basically work on my game, and I'm going to do this in a VM to kind of show from a fresh perspective how you can do this. First of all, let me show you what I will be working with. I wrote a blog post recently. So if you go to my website, and this is this one, what not to do. Some time ago I coded a game, this Batty game, and coded it entirely in assembly. So let me get us to the GitHub page. So the problem is that I coded it some time ago, and the second mistake that I made, well, the whole blog post is about showing mistakes that I've made myself and kind of like showing people what not to do. The problem was that I did not really back up my data, and what happened is that I got a virus. It was like long ago at the end of the 90s, and the virus basically wiped my hard drive, and I kind of lost the source code. So I was able to recover some of it, but what happened, if we go to the actual source code, so again I was able to recover most of the files, but the big ones, like for instance this one, was too big, and what happened, let's see if GitHub cooperates. So at the very end, so you see, like, again, the game, kind of, this is the source code, but then if we scroll all the way down, almost to the end, and again, this is a huge spaghetti file, basically spaghetti code, so yeah, don't look at it. It's again a bad example. But if you can see here from line 5294, pretty much the end of the file got completely clobbered up, and so in other words, I can't build it anymore. And the game is not really worth it for me to recover all this stuff. So what I was kind of like hoping to show here is how can you modify this file, because again at this point I can't build it anymore, and I want to change it a little bit. Again, it's just a kind of like a silly example. Again, if you take a concrete sample from my blog post, like for instance for the main loop, I mentioned here that I was working on timing for the main loop, but what happened is that the timing did not really work well. So let me show you real quick what happens. So if I download the binary, can get it here. And yeah, sorry, I'm doing all this stuff live to kind of like show you how you can do all the stuff. So again, this is just a binary file, so if we unzip it somewhere on your drive, let's say over here, okay, don't need this anymore. Okay, so if we run it, obviously say yes, run it. Haven't signed it yet. So okay, so if we start a new game, not changing anything, so as you can see, everything is really slow in the beginning. You see, like, the ball basically barely runs, and this happens because I was actually writing it on a much slower hardware and also with the different hardware. So my goal is to increase this delay. And what happens in this case, if we go back to my blog post, oops, somewhere in the middle, I'm mentioning a game loop, a main loop, and the main loop is using this WaitForSingleObject function. So if I click here, it should actually take me right to the point in source code. Okay, so as you can see, there is this WaitForSingleObject, which if we search MSDN, sorry, Bing can't just leave me without accepting something. Okay, so if you look at the documentation, the second parameter is the delay in milliseconds that this function waits. Okay, I'm using event here, but it doesn't matter. It's just a delay. And this delay, do Control F, is used over here, set up here as a basically if statement. It's either 3 milliseconds or 4 milliseconds. Now, for the sake of this example, I'm not going to set, too big of a change. For the sake of this example, for the binary patch, I would say that I would want to make this change as such. So instead of doing 3 or 4, I want to specify a smaller delay, let's say 1 millisecond, so that the game is a little bit more playable. Now, how do you do that? Obviously, if I had a source code, I could just change this and, just recompile it. That would be easy. Well, the problem is that I can't recompile it. So in this case, I have to change this in a binary form. And this is kind of like what I mean by a binary patch. So, okay, let's keep this. Okay, before we can go any further, I need a couple tools. First, we need some sort of a hex editor. I would say, yep, this one would work. I'm assuming, yep, that's the one. So let's download it. And let's see, download latest version. And I think English would work. Okay, so we have to set it up real quick. Again, it should be very simple setup. The reason we need hex editor is so that we can actually modify the binary. And let me just do this real quick. Okay, desktop shortcut. Okay, so yep, so this is just a simple hex editor that would let me open the game. And again, the game is, I think I put it into downloads. Yep, it's in Batty here. Okay, so if we open our file, this will give us the contents of the binary file. So what we need to find here is where exactly we can make a patch. And for that, we need some kind of debugger. What I will be using is not my favorite debugger. To be honest with you, it's probably my least favorite, but since most people are using it, I will show with this example. It's a very overpriced and kind of really bad debugger if you ask me, but free version I guess should work. So okay, I'm using Windows. Let's download. It should be pretty straightforward here. So I'm not sure if my internet cooperates here. Yeah, it's going. Okay, so let me get this out of the way. Okay, just the basic setup would suffice, so we don't need, anything extra here. Okay. Okay, well at this point we need to load our game into it. So the easiest way is just to drag the executable into the icon. And I'm sure I have to agree to something. Okay, just going with the basic offering here. And no, we don't have symbols. Again, I'm showing an example, kind of like in the worst case, if you don't have symbols. Now, this software is very square in my view, so let me, it's really slow and stuff. I don't know what it's doing, but anyway, so let's have it finish its thing. Let me see if I can change the font so you can actually read this. About 16. Oops, no, wrong button. Okay, so that should be better. Okay, at this point, let's just run it through a local debugger. Let's make sure it works. Okay, and it does. Okay, at this point we need to, what I'm trying to do, I'm trying to catch the moment when this function is called. Now, since I'm the author of this source code, I know that I'm not using this WaitForSingleObject pretty much anywhere else. So that is why I can put a breakpoint and kind of catch it right on this line. Okay, but before we do that, I need to actually start the game. And here you go. Have to get the mouse. Okay, so at this point I can pause the game. And let's see, okay, and we got paused somewhere. Now at this point it's just paused, so we don't know where exactly the breakpoint triggered, so obviously it's not where we wanted. And the place where we want is, again, this WaitForSingleObject. And the goal here is to break on this line and then scroll backwards a little bit and locate this line. And if you remember, we need to change it from what it was before into simply setting it to 1. So again, this is our binary patch here. Right? Okay, so again, like I said, we need to locate this thing in our binary code. And at first we need to locate the module that it's in, and the easiest way to do it, if you Google search it, not Bing search it, unfortunately, I'm using default browser, so it defaults to Bing, but anyway, what you can look at the very bottom of the MSDN page is the actual DLL that the function resides. So we need kernel 32, and if you scroll, sort these modules and double click on kernel 32, then you can do Control F and type WaitForSingleObject. In this case, it's adding this little prefix here, but this is exactly what we need. So if we right click and add breakpoint and just go with default, that should add a breakpoint. So now when we run the game, it should immediately break on that function. And it has to download something, and here we go. So we are in WaitForSingleObject. We're in kernel 32. So what happened is that right now we broke inside this function, right? So what we need to do, we need to return from this function out. And the easiest way, you know what, the easiest way is actually to find a toolbar. Sorry for this. Let's see, debugging, breakpoints. Yeah, that's what I don't like about this app, is that it's not very helpful. Okay, I think it's F8. Let me just try. Yeah, it has to download something, so in the beginning it will be pretty slow, especially when you're using it the first time. So I'm just waiting for this thing to finish its thing. I'm assuming it has to download some symbols so that we can actually see what's happening, but at this point, okay, yeah, so if you keep hitting F8, it will be stepping over the functions, and we keep going until we actually catch the moment when we leave this WaitForSingleObject. And as you can see, not sure if it's obvious at this point, we have reset event before and WaitForSingleObject. And if you remember my source code, here's reset event and here is WaitForSingleObject. So what we're seeing here is the compiled source code from here. So what we need to do, we need to find this line, which will be literally right before reset event, which is this thing here. Now, if you look at the assembly code, so this highlighted stuff is exactly this if statement. So if double play is true, the value will be 3. If it's false, it will be 4. So This parameter here is our double play, so it puts it in ECX, it negates it, and does kind of like sub B, basically it's subtraction with borrow, and adds 4. So if it subtracts with borrow, ECX will be -1, and it adds 4, which will be 3, otherwise it will be 4. So what we need to do is remove all this stuff and basically set ECX to 1. In this case, we will need our hex editor to locate this code so that we can actually issue the patch. Now, the way you can see, you can locate this stuff is by finding machine code first. So what we need to do, we need to go into General and Disassembly and set this value, number of opcode bytes, to 8. Okay, and right now this thing gives us the actual opcodes for these instructions. So we can copy it, and thank you Windows Defender for interrupting. Okay, so if we paste it here and clean up this garbage a little bit. So what we're actually looking for are these bytes. These bytes are machine code for these 5 instructions. So to make it more usable, what I will do, I will copy and paste all of them into one line so that I can later use them in a hex editor. And the reason I would use them in the hex editor is so I can use search, so I can find these 5 instructions. But before we do that, we need to see how can we substitute these instructions with move ECX1. Oops, sorry. And again, the reason I'm putting ECX1 is because of this line. I want to set it to 1 instead of this. Okay, now some of you might know what this will be in machine code. I don't. I usually go to online disassembler, and let's say disassembler online, and let's see, this one is the one I'm using the most. Again, it's up to you which one you would prefer. So we need to assemble, in this case it's x86, and the reason you can tell it's x86 is by analyzing the code, or actually I think in the beginning it showed us the type of the module, but I can tell right off the bat that this is x86 or 32-bit. Okay, so again, I have to select architecture, x86, assemble, and what we need are these things here, and these 5 bytes will be our instructions here that we have to replace all this gibberish with. Now the problem is that the length of this stuff will be shorter than here, so we have to fill up this stuff with something. Now the way Intel x86 works is that you can't just like keep adding zeros. What you need is a NOP, or no operation command, and again we can receive it here by just adding like so, just to see how it will be in machine code. I know that it's 90 hex, but that's how you can learn. So instead of 0 at the end, we need to do this kind of thing and just keep going for the length of this whole shebang. Okay, so at this point we're ready. So if we take this, and by the way, we don't need our executable anymore. Let me kill it quickly. And at this point, let me close it. I don't want to save anything. Okay, so we have our binary. So let's open it in hex editor. Again, I'm just dragging into it. Okay, and let me copy the whole shebang. And what I'm doing is I'm using search, and I'm using hex values. Let me paste the whole thing. And here you go. So this line here is our highlighted part is the machine code that we have to replace with our bytes. Now, just to be sure, let's try to find again, just to make sure that there is no more occurrence of this line, because obviously if we found more than one, we have a problem. And this would happen if you, let's say, searched by something shorter. Okay, well, at this point, we just need to replace it with this. So let me just move it down this way so we can see it. And just to kind of show, it has to be 90 here, so I can see the end. Okay, and it started from 8B0D, which is this. Okay, so we go with, let me just move it here. So we're basically putting this stuff in there. Okay, so we go B9, 0, 1, 0, 0, 0, 0, 0, 0, and then we do 90 all the way till the red line. Oops, not 99. Anyone who saw the Martian, you probably saw the episode when he was patching the rover, which was quite realistic. So this is how you do it. Okay, make sure you put everything correctly. So B, again, I'm taking it from here, B9, 0, 1, 0, 0, 0, 0, 0, 0, and a bunch of 90s. Okay, so all we have left to do is save it. Let's close this. Okay, well, just to make sure that it actually worked, well, one way would be to test run it, but before we do that, let's just put it into disassembler again and see if it works. By seeing a disassembler, you can actually see the assembly code, which should kind of help us to see if our binary patch worked. So again, I have to wait for this thing to do its thing. Again, if we run it, oh, did I say no? Okay, it should be yes. Okay, so if we start a new game, and I have to Control-Alt out of it to stop it. So again, it has to download something, so again, just give it a second. And we're kind of doing the same thing. Let me see, I think it had breakpoint windows here, I'm not sure, probably didn't save anything. Yeah, I didn't save anything. Okay, so but we can just recreate it real quick. So if we sort modules, we need kernel 32. We do Control F, wait for single object, right click, add breakpoint, okay, and let it run. Okay, so broke here. Now let's do F8 until we leave the function. Okay, so at this point, let's scroll up. And as you see here, we replaced those previous instructions with just setting ECX to 1. Now to confirm, you can put a breakpoint on this line, right-click and add breakpoint. Let me run. Okay, so we stopped here. And if we look at the registers, so EAX is the one that gets the value of milliseconds. And EAX is 4. Let me see, why is it 4? You know, just to confirm. Oh. Well, this is really stupid because what we did, we also replaced this instruction, which we shouldn't have done. So, my bad, so let me do it one more time here. In this case, but this is how you check your work. So you see I basically put too many 90s here, so it kind of like didn't work. So you see the live example when things can go as planned. So let me just start over. It's pretty easy to undo it. Okay, so what we do here, pretty much the same thing. We put this into hex editor. In this case, let's look for this sequence since we just changed it. Oops, not here. Okay, so we have 1, 2, 3, 4, 5, 6 bytes at the end, which is 1, 2, 3, 4, 5, 6 that have to be changed. So we're doing 89, 0D, 70, D0, 43, 00. And again, I added this, which is this command. So what I'm doing is basically adding this. So we move 1 into ECX and put ECX into our milliseconds. So let's save it. Okay, and start over. So again, we'll load it into our disassembler. And no, we don't have symbols. Okay, we have to click Run to start the debugger. Again, I'm just letting it finish its thing. Okay, yes. Okay, new game. Again, Alt-Tab to get out of there. And again, I'm looking for kernel 32. Over here, Control F, wait for single object. Right click and add breakpoint. Okay. And let it resume. And then I F8 out of it. Okay, so let me put another breakpoint over here. Oops, sorry. Okay, so at this point, as you can see, I added this command here. So technically, when we break at this point, EAX should be 1. Again, let me let it run. And as you can see, now EAX is just 1. Okay, well, let's see if it works. Again, I guess we can run, but let me just kill it here so I can show it to you live. Okay, so here's the game. Well, one example is that if it didn't work, the game will crash, because obviously, if you put something weird in the main loop, it's not going to work well, and the game will crash. Okay, so right now, again, it's not perfect, but at least, it's a little bit faster. And this is an example how you can make a binary patch for an executable. Obviously, keep in mind that if the executable was code signed, it will break the code signature, but in that case you just have to rely on it not being code signed. Okay, well, anyway, this is just a short example how you can do a binary patch. Thank you for watching, and see you next time.